We can.
Thank you. Okay, excellent. So, as Mason mentioned, my name is Scott Fincher. I'm a data scientist on the education and evangelism team here at KNIME. And what that means practically is I go around kind of doing talks like this and workshops with folks to help them understand how to use our tool, because a lot of times people aren't familiar with it, haven't heard of us before. So, what I wanted to do today is talk to you a little bit about KNIME, both the company and our software is where we'll start. And then I wanted to show you a demo of the software uh, using the airlines data set for some classification modeling. And I'll walk you through how we can do using a graphical user interface and a low code approach, some loading, transformation of our data, do some visualization, and then also build some different models and compare how they all work together. If we have time at the end, I can also show you a little bit of a deep learning demo with Keras, which we can also we could build neural networks in KNIME using what we call nodes without any code. We almost certainly won't have any time for the text analytics demo, but I leave the slides in here in case that's something that you're interested in. If you do NLP or something, you can see what our examples are. And then we'll have time a little bit at the end for some questions, I hope. So let me start first off, for those of you who are not familiar with KNIME, what is KNIME? So uh, KNIME, the company, we were founded back in 2008, so we've been around about 12 years now. Uh, we were founded in Zurich, Switzerland. That's where our headquarters is. We also have offices in Constance and Berlin, Germany, and more recently, about 3 years ago, an office in Austin, Texas, in the US, which is where I'm based. And so, as a company, we have two different pieces of software that we maintain. One is the open source KNIME Analytics platform, and that's what I'm going to be showing you today. It's free to download. We don't put any restrictions on the amount of data you can process with it or anything. And it is a comprehensive tool for loading data, processing that data, doing transformations, visualizations, analyzing, testing, training, and deploying models. So the key to KNIME is that it has this visual front end, which I'll show you. Everything's GUI based. And you can blend all sorts of data, everything from local flat files on your machine up through stuff that you may have in a database or pull from a big data setting somewhere. And we like to integrate with other open source tools since we're open source. So tools like R, Python, H2O, and Spark, all of which I can show you today. To be able to pull things in from other tools you may already be using. We've been doing biannual or twice a year open source releases since 2006. We generally do a release in the summertime. We had one just about 6 weeks ago, and then we also do another one in December. And we're really committed to the idea of open source. You can always, if you want to understand how one of our particular algorithms works or something, you go out to Bitbucket or GitHub and check the code yourself. And when we release extensions, we release them under the open source umbrella so that it's not something that you're having to download and then pay for things. You're getting it for free for the KNIME Analytics platform. And often that leads to the question, well, how do we keep the lights on as a company? How do we pay the bills if we're just giving away free software all the time? And the answer to that question is we do have another product called the KNIME Server, which is our commercial offering. And the idea is if you're an individual data scientist or you work maybe on a small team using the open source KNIME Analytics platform, um, you can use it free, you can do whatever you need to do, but there may come a point where you need some additional features like being able to collaborate and exchange workflows with the folks on your team. In particular, being able to do version control, being able to schedule and automate deployment of models. That's where the KNIME server comes in, and it's aimed at companies and more of an enterprise. So we sell that software, and that's how we pay the bills, so to speak. The KNIME server also allows you to build workflows, and then you can make them available to other folks like business analysts who haven't seen KNIME at all, um, and execute those workflows via a web portal. So that's the concept of guided analytics, being able to put a product that you've built in front of someone who doesn't necessarily have your knowledge of KNIME, but still for them to be able to use it, a dashboarding approach. That's something else supported on KNIME Server. And again, this is something that we've done several releases for going back to 2008. But enough about the company and all of that. This is what KNIME actually looks like, and I'll show you some more of this when we walk through the demo here in a little bit. Um, we basically go from left to right. We bring in these little colored boxes, which are called nodes. We connect them together to build a workflow, and then maybe you do some visualizations along the way. So if you're new to data science, or maybe you're not new, you may have seen R.A. Fisher's iris data set, which is what this plot is. Everybody's seen this plot a million times probably. But all sorts of visualizations that you can do. So we'll look at some of those in the demo. Um, the idea of KNIME, the kind of building blocks of how it works, we use these nodes. Here's a group by node up here at the top. So the data flows from left to right. It comes into this little triangle, which is an input port. Something happens within the node, and then it flows out on the right. That's the output port. And then we have this little traffic light at the bottom, which is a status indicator that, if it's green, yellow, or red, gives you an idea of the status of the node. If it's green, it's executed, you're good to go. If it's yellow, you need to change some options. If it's red, something has gone wrong. So we take these nodes, we connect them together on these branches to build what we call a workflow to build out our task. And you can see all these different colors. These different colors represent categories of functions in KNIME. So generally, the reader nodes, wherever we're going to be reading in data, that's going to be orange. Blue nodes here are going to be some sort of visualization. Yellow nodes are for transforming. Green or for building models and applying them, and so on. So we have this color scheme that kind of helps you understand when you're looking at a particular part of a workflow what it is exactly that you're trying to do. And then ultimately, we also have a feature called components. So I could take this entire, model building workflow and condense it down into what we call a component. It's a way to encapsulate complexity in a workflow that you've built, and also a way to share functionality with other people. So maybe I wouldn't boil my whole workflow down into a component, but maybe I have some document pre-processing steps in an NLP context that I constantly am doing. Things like removing punctuation and uh, stemming my words and stuff that I do every time I read in some text. I could condense that into a component and then share it so that other folks on my team, or even I could publish it publicly, folks throughout the world could use that. So you can think of a component like as building a little function or a library in a coding sense. So this is what things generally look like. Just kind of wanted to introduce you to those concepts so when we start walking through the demo, you'll already be familiar kind of with how things flow. So this is kind of a marketing slide, really, just to show you all the different things KNIME can do, all the way from, as I mentioned, reading in data from different sources, whether that's local or databases, or even big data, Hive, Hadoop, Impala, doing transformation with these yellow nodes, right? Row, column, matrix transformations. Um, Analyzing data. This is where I think KNIME is actually really strong, in this green section in the middle, because we have a whole bunch of different model algorithms to bring to bear on your data for whatever type of problem you might be looking at, whether that's classification or clustering, image processing, text analytics. We have nodes for all that sort of stuff. Blue nodes for visualization, whether that's exploratory or diagnostic visualization, and then deployment. Maybe ultimately I'd like to build some sort of automated report to send to my boss, or write out a model somewhere to use later, or write other flat files. Ways to get data, you know, that you've analyzed back out of KNIME somewhere else so that other people can actually make use of it. This has over 3,000 native and embedded nodes included, which seems to me, I think, a little intimidating. If you've never used KNIME before, you may see that number and think, how in the world can I learn 3,000 nodes? Like, that's ridiculous. And what I would say to you is, don't worry about that. You can be very effective using KNIME, um, using a very small subset of those nodes that are particular to the task that you're trying to do. You may only need to know 15 or 20 different nodes, for example. I certainly don't know all 3,000 myself, not even close. So, like I said, this is more of a marketing slide, just kind of show you the different things that KNIME can do. So, if you are listening to this and quickly becoming bored and falling asleep, then that's fine. I would encourage you to go and download KNIME and play with it, because it's a lot more interesting to try it out than it is probably to listen to me talk sometimes. If you want to do that, you can go to knime.com. and click on the big yellow download button on the top right-hand side of the page. As I mentioned before, it's completely free, no restrictions on the amount of data that you can process with the analytics platform. We also have some other courses out there available to help you learn to use KNIME in the context of kind of beginning data science sort of stuff. Um, One that we offer on our website, and another one that we've put together and put up on Udemy that's mostly video content. It's about 4 hours of video content. We also have some books available via Nine Press, one of which I'll give you a code for at the end of this presentation. So you could download the book. It comes with exercises and workflows, just a way to cement kind of what you're learning as you go. Okay. Oh, one more thing, I guess, before we get to the demo, the hub and the forum. So we have a website out there, the hub called it's hub.nime.com. This is where you can get access to different workflows, to different components, um, to different nodes. So uh, folks in our community as well as folks on the KNIME data science team upload workflows for different use cases, right? Maybe you need to start working on a churn prediction sort of example, right? And instead of starting completely from scratch, you can go to the hub and find one of our existing churn prediction examples, download that. It's going to come with data, and then you can start playing around with it, get an understanding of how the workflow works. And once you know that, then you can swap things out with your own data set and start applying and doing what you need to do. So we have all sorts of different example workflows for you to explore, as well as components and whatnot. So um, check that out at hub.nime.com. Then at our forum, which is at forum.nime.com, we have a really active user community that is available to help you out with your questions. I myself am also on the forum almost every day, trying to help people, work through problems with their workflows, or there's a bug, or why isn't this, doing what I expected it to do. Our community is really great, so I encourage you to check that out as well. Okay, enough of me blabbering about slides. Instead, let's look at a demo so you can actually see how the tool works a little bit better. So the first demo I'm going to show you here is a classification modeling demo using the pretty well-known airline flights data set. You may have seen this data set on Kaggle or some other places. Um, what we're going to be using is really a combination of a couple different data sets. So one is from the US Department of Transportation. It's on-time statistics data from 2009. And what that contains is a bunch of information on different flights going from airport to airport throughout the U.S. Information, how long was it in the air? How long was it taxiing on the ground? Which carrier is it? Which individual aircraft was it? All sorts of information like this, just about planes going to and fro from these different airports. And the other data set that we're going to combine with it is some meteorological data from NOAA from that same time period. So, is it raining in Chicago? Is it sunny in New York, right? What's the temperature? That sort of stuff. So, what we want to do with this data is we want to try and predict departure delays for these aircraft. So, given what we know about these things, can we predict whether an aircraft is going to be delayed, where we define a delay as an aircraft leaving more than 15 minutes late? So to go through this process, I'll show you some basics of how we load and transform data in KNIME, and then also some simple visualizations that we could generate in KNIME, also calling in R and Python where we think that that might be helpful. And then we'll build several different models. We'll use several different algorithms, but we'll also use some of these other open source integrations that are available too. So you see them listed here. We'll, these are all pretty standard classification algorithms, but we'll use Python, R, H2O, native KNIME nodes. And then if we have time, I'll show you a little bit about logistic regression running on a local Spark cluster. And then ultimately we can see how all these models perform and compare the results. So let's switch over to KNIME and actually look at this. So here's the tool itself. Um, Before I dig into what's going on in this workflow, I'll just show you a little bit about the interface. The top left up here is the KNIME Explorer. This is where I have all of my different workflows and workflow groups for stuff that I've been working on. I also have connections to the hub that I mentioned before, as well as a KNIME server that I'm connected to. Down here in the bottom left is the node repository. This is where all the nodes live. So if, for example, I want to read in an Excel file, let's say. I can go to the IO section of the node repository, go to read, and there's the Excel reader right at the very top. I also could have searched for something, like if I want to read in CSV files, I can type CSV, search for the CSV reader, and I can see a couple of different ones pop up. So there's many thousands of nodes here in the node repository organized by the type of task that they're supposed to perform. Then on the bottom right here, this is our console. So this is just going to give me in real time as I execute my nodes, warning messages, error messages, and so forth. You'll see this kind of change as we look at some of these results of things. And then on the left-hand side over here, I'm sorry, the right-hand side is the description pane. So this is context-sensitive real-time help for any nodes that I click on. So I'm clicked on the Data Explorer right now. It's going to tell me all about the different options available with the Data Explorer, as well as the input and outputs that's it expects at its different ports. Um, if this was a particular algorithm like the random forest, it would probably also have links in here to the paper that the algorithm is based on, so I could dig in and do some more exploration. So that's kind of a quick 2-minute tour around the interface, but let's actually talk about what's going on in here for a second. So on the left-hand side, and let me blow this up a little bit. On the left-hand side, I have this gray box here. This is called a meta node. It's a meta node because it actually contains other nodes inside it. So to go inside this meta node, I can just double click on it, and that's going to open up for me a different tab with some other nodes and other meta nodes. And so you can see I have some of this annotation, these colored boxes, and I have descriptions below each of my nodes. You can think of this as like comments that you would write in code, right? Whenever you have a GUI tool like this, it's a really good idea to add these types of annotations and comments so that later on you can understand what it was that you were doing, or if you hand this off to someone else, right, they can understand what you're doing. Starting at the very beginning here, we have this table reader file. This is where we're reading in this airline data set. So whenever I have a particular node, I can always do a couple things with it. I can double click on it to see its configuration. So for the table reader, there's not much to configure. I basically am just pointing at a file on my local system. This contains all of the different, it contains the data itself, but then also things like headers and variable types and whatnot in a table format, which is KNIME's custom kind of internal format. This could just as easily be an Excel reader or a file reader or something else. And then once I have configured this node and executed it, I can always look at its results by right-clicking on the node, going down to the bottom, and looking at the tabular view. And so this is where I can see, okay, inside my data set, for my flights, I have year, month, day, departure and arrival times, flight numbers, taxi time on the runway, weather delays, all of this sort of stuff is in here. So then let's say, maybe the next thing I want to do is some sort of transformation. So I'm using this yellow transformation node in this example to convert my strings to a date and time format. So if I look at the configuration of this node, since it's doing something different, the configuration is going to look different too. So in this case, I'm taking my date here that's in string form. I want to convert it to a date and time so I can do some other extractions on it later. I tell KNIME, here's what the format is. I execute the node and run it, and then I can look at my results. I'm not going to walk you through every single one of these nodes because we don't have time to do it, but I wanted to point out just these first two because this illustrates another, I think, important concept of KNIME, which is this. At, at every state in your workflow, you're able to see what your data is. So after I apply, for example, this very first transformation, just converting my strings to a date and time format, I can go in and see, okay, what did I do? I can look at the output table, go over and find my date and see that, okay, now it's actually is in the proper format. I can look at the column up here and see it has this little calendar icon, which indicates that it's now a native date and not a string anymore. What KNIME is doing is it's saving the state of your data at each point in the workflow. And why that's important, right, is because you can easily think of cases where, I joined some data sets together, but I joined them on the wrong key, and that's why everything downstream looks weird. I need to go to this part of my data blending node and make that change, right? I only have to go back to the part where the mistake happened, fix it at that point, and then when I execute it, I only have to worry about the stuff that's downstream. All the stuff that's upstream is going to, be the same. So it helps me in troubleshooting and fixing bugs that I may have introduced into my workflow. But also, it's just nice to check periodically at points along the way. What's the current status of my data? What does it look like? So there's other things going on here. We do some things like filtering of data, applying some rules to label our data along the way, do some renaming. We do some blending here on taking the meteorological data and bringing it in together with the existing flights data using a joiner. Some of these typical ETL things that you would do as part of cleansing and manipulating your data prior to doing some modeling. This is all stuff we can do in KNIME here. And this workflow is publicly available, so you can explore this later if you have time. So let me get on to the next bit here where we're actually building some models. So um, if we take what's coming out of this data processing node, I have 3 output ports. So I have my complete data set coming out of the top. I have a training set and a test set on the bottom. I split the training and test set using the row splitter because we're going to take the first 15 days of January 2007 as our training set, and then the latter half of that month as our test set. That's maybe not normally how I would partition things. I might usually use a partitioning node to split the data. But here, since it's kind of time series data, that's why we're doing it this way. But I also wanted to just keep the entire data set on this top port here to show you some of the visualizations we might do. So for example, all of these blue nodes up here, these are doing different things. I have a node here in KNIME called the Data Explorer. If I look at the results of it, I can see at a glance what's going on with my numerical and nominal features in my data set. So I can see, what's the minimum, maximum, mean, standard deviation, all the way out to the second and third moments statistically, if you care about that. As well, more interestingly, probably the number of missings in my data, the number of zeros, and I even get a little histogram on the far right-hand side that indicates, skewness, which I may care about for some particular features. Maybe I want them to be more normally distributed or something. I can see that at a glance. So this just helps me as I look down through my data set to see what the distributions are for my numeric values. I also can see for my nominal values, how many unique values I have. KNIME is highlighting this for me. For example, the tail number of my aircraft, I have more than 1,000 different unique values for that. That's probably an indicator to me that this is not something I want to use in a model, right? This is not going to be useful. I should clean this out. So I could look at things using the Data Explorer. Now, I may also instead want to look at my data using visualizations that I prefer from R or from Python. And this is where the other kind of open source tools can come into play. Maybe I want to generate a pairs plot in R to look at how the meteorological variables may correlate with one another. So I'll show you the view first and then show you how it was built. This is a pairs plot where we're comparing, for example, snow depth versus maximum temperature to see if there's a correlation. And I can see at a glance, it gives me a little scatter plot. I see that there's a slope here, which indicates, there is a correlation, as you would expect, between snow depth and maximum temperature. And then I also get the slope of that line numerically up here in the top right. So, this is a view I could generate in R. And to do that inside the R view table, I can just write a little bit of code. And just one second, my electricity we have storms in the area, so there we go. I thought for a second the demo gods were gonna frown on me. Okay, so what we have here then in the configuration for this node is just a little bit of R code to generate this pairs
Scott,
plot.
can you zoom in on this because the window is so small I can't see anything.
Um, for the dialogue, let's see, can I make this bigger? Unfortunately, I don't think I can. I'm sorry about that.
All right.
Um, I should be running with a smaller resolution on my screen, I guess.
And can you use magnifier if you are running Windows?
Um, maybe. I'm
I
gonna
guess can be with bandwidth as well. So I'm turning off your camera, Scott.
Okay.
Maybe that will make the screen a bit better, not blurry.
I will say that the code here is not that interesting.
Mm-hmm.
It's
Okay.
it's really just a few lines of R that are generating this plot. Um, and I just wanted to show you that
Okay.
it's possible to, I could put this code in, I could run it line by line or section by section to generate it. And then I have a little console down here that would give me the results. I could do
Okay.
something
Great.
similar. I could do something similar using this Python view. Um, if I wanted to generate, for example, this is kind of a silly example, but a pie chart in Python, I could, import matplotlib to do that, write a little bit of code here to generate my pie chart, and then I get this rather silly looking pie chart. Why would you ever care about this? The flights by the day of week, right? So just to show you, again, the code that builds those is not very interesting. It's more to show you that in KNIME, if I want to generate this sort of visualization, I could do it with native KNIME nodes without using any code. Or if I do prefer to write some code because I have something that, already handy that I like, I could do that as well. So apart from the visualizations here, let me show you some of the models. So I have all these different models here. We don't have time to go through all of these, unfortunately. One is the KNIME decision tree here, the fourth one down. If I click on this meta node, I can go in and see that I have a decision tree learner and a decision tree predictor. So whenever we build models in KNIME, we have this learner predictor motif is what we call it. We always have a node that's going to train the model using the training set, and then a node that's going to apply that model to the test set using a predictor node. So to train a decision tree, I go into the configuration and say, what's the thing I'm trying to predict? In this case, it happens to be the departure delay, which is a 0 or 1 binary variable. And then I have other options for applying pruning and things if I need to do that. Once I build the model, and I could even visualize the model, the decision tree as well here if I wanted to by looking at the output from the learner, dig into the different levels of the decision tree. I can apply that model using the predictor, and I can even apply the columns with the normalized class distribution or the probabilities, which is going to be useful because ultimately what I want to do is look at the accuracy, how well this model predicted just from an accuracy standpoint, which I can get from the scorer. I can get the confusion matrix and accuracy there. But if I keep those probabilities set aside, I can also generate a ROC curve. And so that's what we're going to do for each of these different models that we build. So I could do that. This is all no code using the KNIME native decision tree. I also could do this in Python using, for example, a random forest. So again, here we have, even though we're using Python, we still have the learner and predictor motif here. So again, apologize for the really small text here. Sorry about that. But what's happening in the code is not much. It's just a few lines of code where I'm importing the random forest classifier from sklearn, and then I'm applying that algorithm over different vectors that I've identified in my input data set. So this is taking a KNIME table that we've already done the processing on as input, and then it's building the model using sklearn. And then we're going to take that model and send it to the predictor. Again, just a few more lines of code here to say, apply this previous model. Here's some different features that we can ignore, et cetera, and then see what our results are. And what we get out of that predictor node is a KNIME table that is going to have all of our original data set in it, which is fine, but all the way over on the right-hand side, the prediction that we're getting out of the random forest, as well as the associated probability. So again, we could look at the results of a confusion matrix, for example, since this is a binary classification problem, um, get an overall accuracy, and save those probabilities for use in a ROC curve. I know that I'm running out of time here, so I'm going to skip ahead just a little bit. What are the results if we were to do this, so we could build a model in Python, we can reach out to Python, have it do the model and bring the results back. We could do the same in R. We could also use H2O.AI. In this case, we use the gradient boosted machine. I don't know if you're familiar with H2O or not, but it's some algorithms that were built by some guys in Berkeley, California, that's highly performant. They run really fast, and they scale really well. And we actually have a pretty tight integration with the different H2O algorithms within KNIME. They have their own nodes. We still have this learner predictor motif that I mentioned before. This section of the workflow looks a little bit different because you end up converting KNIME tables to H2O tables to actually have it do the modeling. But then we bring it back out to regular KNIME tables at the end to get the accuracy and ROC curves and so forth. So if you're familiar with H2O, as I mentioned, we have a really tight integration with them. So ultimately, what does this look like? If I want to look at the ROC curve, for example, I've combined all these different model results, and then I use a ROC curve node to plot it up. If you're familiar with ROC curves, then you know that what we're attempting to do here is minimize the false positive rate on the x-axis and maximize the true positive rate on the y-axis. So we're trying to pull these curves up to the top left-hand corner such that the area under the curve, the higher it is, the closer to 1 it is a good indicator that the model is performing well. It also, if you know anything about ROC curves, you know that this is a suspicious plot. These curves are too good. They're too far up to the left, and the reason for that is it turns out that when you're trying to predict airline delays, if you include the arrival delay for your aircraft as part of the feature set, then you can predict departure delays really, really well. So that's an example of data leakage, something you would actually want to avoid in your analysis, because you start to see suspicious things like this. But the good thing is we're not falling along the coin flip line, this 50% line. So anyway, I've got, Mesum, I think I have about 5 minutes maybe before questions, or you let me know if I need to stop and answer questions here.
Yeah, I
Uh,
think I would prefer if you can just skip to the questions because there are a lot of them.
Okay, so let me just wrap up then. I
Right.
do have other sections here in this workflow that we just don't have time to discuss, unfortunately, but
Mhm.
you guys can look at the slides later and
Maybe
kind of
you could,
explore
yeah,
a little bit more.
yep, that would be better.
So there's a little bit more on the Python integration. One thing that I did want to mention, because I think we have a lot of Python folks here, is
Mm-hmm.
you can call Python from within KNIME, as I showed you, but you can also call KNIME workflows from within a Jupyter notebook as well. When you make that call, you'll even see an image of the KNIME workflow here. So this is, if you like using Python and you want to work together with KNIME, we try to make that easy for you to do. More information here available for the different workflows that I've showed you. Um, and I'll skip through some of this stuff on deep learning and text analytics. I wish we had time for that, but we don't. I do want to mention that we have available these books at KNIME Press. Please go out to knime.org/KNIME Press and use this promotion code Karachi-0820 for a free copy of the KNIME Beginner's Luck book, which comes with a bunch of exercises and will kind of introduce you to how we can, build models and do transformation of data in KNIME. The same code will also work for a 20% discount on our upcoming level 1 courses at the end of August and the beginning of September. So again, if you're interested in exploring more and you'd like some live instruction taught by data scientists on our team, then you can register for some of these. And having said that, I will stop here